Hello, this is a video to walk you through what was discussed in recitation this week. If you had attended recitation, you may not necessarily need to watch this video. I do get into a couple problems towards the end of the activity that maybe if your TA didn't cover them, you could skip ahead to those. So hopefully your TA, lets you know if they maybe sent an announcement or if they showed the slide, their name. Hopefully their recitation time location is understood. Maybe they shared their office hour time with you, but try to find maybe when you can track them down in the various locations they may be holding their office hours. And then also know that we have a Learning Resource Center available where you can seek out help from any of our Chem 12, 10, and 20 TAs throughout the semester. Some basic information on recitation. So recitations meet weekly during the 55-minute quote-unquote lab meeting on your schedule. Exams are given in recitation weeks 4, 7, 10, and 13. And then the weeks that we don't have exams, then we'll generally be working on activities. And for the most part, these will be graded for attendance and participation starting week 2. And then the very last recitation during the last week of the semester is a day where attendance is not required. So generally, you get 10 points for attending, participating. Your TA may ask that you submit your work after class. But doing that, attending, should be very easy to get these 10 points. The goal is come to class, learn a few things, maybe work in a group, and then just productively, try to advance our understanding of the material. You get one dropped assignment throughout the semester to allow for one absence for any reason. You don't need to email any of us to get that drop. If you miss that week, you'll get a 0, and that lowest score will be dropped automatically in Carmen. If you possibly need a makeup for a second or additional assignment, just make sure to contact me if you have a valid reason, or if you believe you have a valid reason for missing recitation. Email me and I'll let you know if we can come up with a makeup situation for that. But generally speaking, try to reserve your one drop for that one time you may need to miss recitation, so that we're not having too many situations where we get requests for makeup assignments. You can bring questions at the start of recitation. I'm sure your TA would be happy to try to answer any questions you have that the entire room might benefit by taking the time in class to answer. If you have some very specific questions that you want to ask your TA, email is a great method to contact your TA. Maybe seek out their office hours, my email, or like I said, that Learning Resource Center. And hopefully the goal of recitation is to provide you with an activity to help assist your learning and to give you a chance to practice the material, and also to get some small group help and work within a smaller portion of the class. This is the recitation information or the schedule from the syllabus. I just wanted to highlight a few things here. And so I just wanted to highlight, again, the first week, just an intro, not graded. Activities 1 and 2, that's where we start grading things week 2 and 3. Exam week 4. Activities weeks 5 and 6, etc. Exam week 7. You can kind of see we do about 2 activities, take an exam. I had pointed out in class that when we get to this election day, we were asked to not hold in-person class. I'm not entirely sure what that activity will look like, but we'll have something planned for the week when we're not meeting in person, synchronous or asynchronously. So hopefully your other classes are following suit so that you have the ability to travel back home if you want to travel home, if you're able to vote in the U.S. election. And if not, or as an alternative, highly recommend suggesting that you request an absentee ballot if you're allowed to do so. That might be a great way to avoid having to travel back to wherever you're from if you were hoping to vote. Then we take exam 4 the following week, have a couple activities. The very last week of recitation, the week after Thanksgiving, we just have a review activity planned where you can attend here if you wish. We will hold recitation to do an activity that just is an ungraded session. So how to best contact all of us. So my best contact's email or dropping in office hours. I'm happy to take questions before and after class. Your TAs can fill in their information here or let you know that through announcements. But generally, email is the best way to contact most of us here in the course. Email for me is the same thing as the Carbon inbox. If you send me an inbox message, I'll just reply by email back to you. So, Carbon inbox or emailing is a great way to contact your instructors. So, we asked you guys to get to know each other. I don't know if I had introduced myself, but I'm originally from the Youngstown, Ohio area, Hubbard, Ohio, for anybody who's heard of it. My major and career goal was to study chemistry. I pretty quickly wanted to do something in the form of education. So I've been here at OSU going on year 17 teaching. This is the 16th year in a row I've taught General Chemistry 1 in the fall. So that's exciting for me to kind of see the evolution of a class that I feel like every year we do get a little bit better in terms of being student-centered in our approaches. And I think you'll see that both in terms of some things we do in lecture and even the lab's gone through some modifications that make it a good improvement from years past. So I think we changed this in your version to say, would you guys do fun over autumn break, but or over the summer? So hopefully you guys had a good chance to do something fun over the summer. If you get a chance to drop in office hours, I'll probably ask you in the first couple of weeks where you're from, what your majors are, and just generally excited to get to know as many of you as I can. So this is related to a little bit of stuff. The point I'm making this video was right after Friday's lecture. So we had just had lecture from my vantage point on introducing some of the terminology here on the slide. That an atom is the basic building block of matter, can be comprised of one of the 118 known elements, that you can have different elements mixed together through chemical bonding to make compounds. And then we got molecules. They're a version of bonding where the atoms are sharing electrons with each other. That's what we call hydrogen, or that's what we call covalent bonding. We mentioned this with water, that this is our covalent bond, that this is the bonding present in things that we call molecules. So water is a compound because it contains two elements. It's a molecule because we have atoms connected together into a molecule. And so something like H2 is a molecule but not a compound. Water is a molecule and a compound. Okay, and so we talked about heterogeneous mixtures, homogeneous mixtures, and so this is just where if we see multiple phases, it's heterogeneous. And it could be two different liquids where we see a separation between the two, like oil and vinegar. Or maybe it's a solid mix in a liquid where you can clearly see the two different phases. So heterogeneous mixtures are usually pretty easy to spot by eye. Things that we look at that look the same throughout, that's what we call homogeneous. Whether it's a homogeneous mixture or if it's just a pure substance, depends if there's two or more components mixed together. And so how can we classify things below? Hydrogen in a cylinder. So this is a element because it's just one substance, and it also contains a molecule because that element exists in molecular form. So I'd call H2, that's the elemental form of hydrogen. It's an element, and then it's also a molecule because H2 exists as a molecule. But it's not a compound because we don't have two different elements present. So I have a container filled with water. I could call this a compound. I could call it a molecule because it's a molecular compound. I could call it just that. There's nothing else I can call it. So just a compound or molecule or a molecular compound. I have a container filled with salt water, which is sodium chloride dissolved in water. Or, just imagine you have sodium chloride dissolved in water. If you don't know what this means, we'll talk about that in chapter 4, the AQ tag. This means something that's dissolved in water. And so for this substance here, we would define this to be a mixture. As long as that salt's completely dissolved, I would call that a homogeneous mixture. So this would be let me change this to be smaller, and then let me erase this here. Oh, come on. No, it's being annoying. I just want to write homogeneous mixture a little bit more clearly. You can see that. So homogeneous mixture. A container, and then we can say water is still a molecule. So water is still a molecule in the sample. NaCl is really dissolved ions. It's a little more complicated. I'll talk about that in chapter 4, but it's not really a compound, perhaps, once you dissolve it in water. But if you had NaCl solid, I'd call that a compound. This thing here, the best description we could give this entire substance, the salt water, would be homogeneous mixture. A container filled with vegetable oil and water with 2 distinct layers, that's a heterogeneous mixture. Should do this thing here. Anyways, doesn't matter. I was going to play around at some point. There's a way I can type and it'll auto-translate it into actual text. I should use that more because my handwriting isn't great. But anyways, moving on. Some element review. This was meant just to be a practice and a reminder on some of the elements that aren't entirely obvious on what the name or symbol is if you haven't seen these in a while. But hopefully remember sodium is Na, potassium is K. We never take a spelling test here. Fe is iron, Co is cobalt, Cu, of course, is copper. And so I think what's useful is when if I give an example where I say, in chapter 3, we'll talk about reactions. So if I say, okay, you have, 5 grams of copper chloride, and you need to look up like a molar mass for copper, then you need to know that that's Cu, where to find out the periodic table. So, just to be able to communicate with each other, we just need to make sure we know the symbol, the name the symbol. So you don't have to reconstruct a periodic table, but it's really just understanding the name symbol pairs for the common elements we'll see in examples. Magnesium is Mg. It's in the second group of elements underneath beryllium, but that's different, of course, from element Mn in the transition metal series. The fifth one across is manganese Mn. Phosphorus is P. A lot of students, if they haven't seen chemistry in a while, get phosphorus and potassium backwards. But phosphorus is P, not potassium. Potassium is K. Silver is Ag. Chromium is Cr, etc. So just knowing the first 4 rows, some of the main groups, a couple of the bigger ones. So we have tin is Sn, platinum, Pt, gold, mercury, lead. And those are some common metals, elements that we discuss and use in examples that don't have, maybe an obvious symbol that goes along with their name. This question here, if you see this on the activity, this will actually be on next week's activity 2. So your TA may or may not have gone over this problem. If they did, they were just getting a little bit ahead of some of the things we'll see next week, or allow us to get a little bit deeper into our first activity that'll be graded next week. So this problem and beyond, we're putting on the first activity for next week. So if you see the next couple of questions in this packet, don't worry about those for this week, and you'll see those next week and hopefully work on them in class. And if you need to watch this video for activity 1, check that out later. All right, guys, have a great weekend.